cryptanalysis is trying to crack the code. It's just like playing Wheel of Fortune or Hangman. If you've ever played Hangman, you start guessing and you're going to get some wrong. And this is the struggle people have, is because they think, oh, this is a math class. I'm an intelligent person. I know how to solve math problems. They're afraid to guess. But please don't be afraid to guess. I need to really, so cryptanalysis is this process we have of decrypting and understanding encrypted message, and as a way of getting at it, and then we're actually going to try to do it. The first time that people actually thought about how to do that and said, we're going to do a systematic way where we determine how to decrypt encrypted messages, was in something called the Abbasid Caliphate, which was in the early days of the Islamic Empire around 750 AD. And there were a lot of aspects of this that made it productive, that made it the right environment for this type of study. The first thing was they did not have any enemies surrounding them. They had a peaceful and wealthy society. They were very successful, and they had no threats. And they were obsessed with the pursuit of knowledge. They wanted to show that they could be, this particular political establishment wanted to show that it was a great empire or civilization. And the way it did that was by showing that it could study the things that other great civilizations had studied and go beyond that. The second thing was, because of the certain things about the Islamic religion, they did a lot of extensive textual and linguistic scholarship related to the Quran. And they were very much into studying languages and studying the structure of language. That was something that kind of connected to what we're about to do, that if you spend a lot of time thinking about words and thinking about what words mean and thinking about difficult questions, it does something in your brain that can't really be described by this pure right, wrong answer. Muscles or agility, where suddenly you start thinking in different ways. And the third thing that gave them a huge advantage in terms of this was they had the technology of making paper, which was not something that was known in Europe at the time, and it was not something that was known to European civilizations before this. They had to write on the fact that you can take a piece of paper, write something on it, realize you're wrong, and write over it again or throw it away was actually a big high-tech thing at the time. And one of the main scholars was Abu Yasim ibn Asaba ibn Amran ibn Ismail al-Kindi, who was born around 800 AD in Basra, which is now, it was in the time what was politically known as the Abbasid Caliphate. It's now Iraq, and you may remember that there were, you probably are too young to remember this at this point, but during the Iraq War that began in 2003, there were battles of Basra. And that was a battlefield that some Americans are familiar with. He's one of the most productive scholars I can imagine. Like, he wrote 290 full-length books on all of these different scientific areas, which is incredible. He died 89 years after he was born in Baghdad, which is the capital of modern-day Iraq, in what at the time was the Abbasid Caliphate. And what he wrote was the first time someone had tried to systematically say, here's how you would solve this type of enciphered thing. People had tried to do it before, but it had always been on an ad hoc basis where they were solving a particular problem. And he was saying, here's a process that you can apply no matter what you're trying to solve. So here is the quote. One way to solve an encrypted message, if we know its language, that's important. You have to know something about the language it's written in, is to find a different message in the same language long enough and count the occurrences of each letter. So you're going to take, if we're doing English, you're going to take a normal English page, and you're going to count how many times each letter occurs. On your sheet, do you have a frequency table of English letters? So someone has done this work for you. Someone has taken a page, a normal page of English, perhaps several pages of English, and they've written down what percentage of the time each letter occurs, and they were really nice. They ranked it in order. If you were doing this back then, you would have had to do this by hand. You would have had to find it and physically count the number of times. You would have still ended up with this information. And then you say, okay, here's the first most occurring letter, the second most occurring letter, until you've ranked them in order and by their frequencies. And then once you've done that, you look at the ciphertext you want to solve and you classify its symbols. So on the other side of this page, I've given you a message about some very simple advice about aristocrats. Aristocrats is another term for a substitution cipher. They were called aristocrats because they were supposed to be the highest level of difficulty. And so what it says is, take your message and start looking at the frequency of letters in the message. And then you're going to have some kind of correspondence. So on this particular cipher, I see that M, G, and S are all the most common letters in my ciphertext. So I'm going to look back here and say, okay, E and A are the E, T, and A are the most common letters in English. I'm guessing that E is represented in this message by one of these really common letters like G, M, or S. That's all I can do. I'm going to make a guess. And I say, okay, well, what if G is E? Is there anything that contradicts that? Well, in looking at this message, I'm having to decide, I'm looking at the first, the most common letters are M, G, and S, and I see the most common letters on the plain text are E and T. And so I'm going to say